This is the video demonstration of a shopping trolley with automatic radio control, or as we like to call it, Starc. Shopping has become an integral part of our lives today. With the opening of departmental stores at every corner, shopping has become easier than ever. People can get anything and everything they want at one place. But there are those who cannot enjoy this luxury without feeling completely helpless. These include people who cannot carry or pull heavy weights on their own due to some reason. These include specially able people, pregnant women, and old age people, etc.
This is the driving force behind Starc. It is simply a shopping cart with the ability to follow a unique user across the supermarket so that user can simply put the items in it without the need of pulling the cart.
Now we will talk about the TI components that are used in the project. The primary component used is the EZ430 RF2500 development tool, which consists of a pair of CC2500 transceiver nodes with embedded MSP430 F2274 ICs. The CC2500 transceiver operates at a frequency of 2.4 GHz in the ISM band. It can be connected to the USB FET debugger to code the node easily. These program nodes can be used as an end device or an access device by attaching them to a battery pack. These nodes also have holes that can be soldered to take output from various ports. The next component used is the MSP430 FR5739 experimenters board with inbuilt FRAM, which provides high write speeds and large number of write cycles. It has onboard accelerometer, ADC, temperature sensor, UART, and J tags. These J tags gives it the compatibility with various Texas RF daughter cards, which also makes it an ideal choice in further product development. Since for mass production, the EZ430 kit can be replaced by similarly programmed RF daughter cards. Next component used is the L293NE which is a motor driver which has an H bridge which drives the rear motors of the cart in both directions. The last component used is UA7805 IC, which gives 5-volt constant supply to the experimenter board as well as the development tool.
In this section, we are going to talk about RSSI, which is a concept that we have used in our project. RSSI stands for Received Signal Strength Indication, which is actually the power of the received signal. Here we have a transmitter and a receiver. The receiver receives the signal and calculates the RSSI value, which is shown on the laptop here. The value is shown by using the software real term. Here we can see the value as 70%. It goes to a maximum of 98 and a minimum of 32%. Here at a distance of 10 centimeter we have seen the value. Now if we increase the distance to 20 centimeter, we have a value 65%. Next, if we further increase the distance, we have a value 57%. On further increasing the distance, we get a value of 50%. So we can see that as the distance increases, the RSSI value decreases linearly with it. And hence, we can calculate the distance using RSSI value.
In order to implement Starc, we require strong signal strength from one direction and simultaneously we require less signal strength from all other directions. So in order to do that, we first tried polyurethane material, but it didn't work because it works only in noiseless environment, but it could not be possible to do this in our project. So secondly, we use mesh. In mesh, what we have, if we use mesh size of lambda by 10, then the region inside the mesh attenuates all the signals corresponding to wavelength lambda. So here you can see a receiver. So receiver receives the signal strength and the signal strength coming from all the directions. If we have a source here, then we have strong signal strength from this direction and less signal strength from all other directions. But if we use a cage with a mesh size lambda by 10 or small, then we can attenuate the signal strength inside the cage. So here signal strength is available, but here it is not present. So in the third one, what we have a narrow opening here. So what we have a strong signal strength from the narrow opening coming inside the cage, and all the signals from all other direction is being attenuated. Now we have placed a transmitter at a constant distance. Whenever the RSSI value is greater than 50, the LED go green. Whenever the value of RSI goes below 40, then this LED go red. So now by means of a mesh, we show the attenuation effect. Here the RSI value is greater than 50, so therefore it is green. In the case the RSI value is less than 40, then therefore the LED go red. It go green, it go red inside. It go green outside because the RSI value is greater than 50.
Now we move towards the working prototype of Starc. Here we have in front the cage which contains the easy 430 endpoint. It is being connected to the microcontroller through these wires which drives the servo and also at the same time gives the signal about the position of servo to the next controller. This controller receives the signal from the easy 430 endpoint and from the other controller which tells it the position. Now after getting the position and RSSI value, the driver is given a signal corresponding to the position of the user. The RSSI value is maintained by this controller here and it calculates the apparent position of the user according to the RSSI value and further gives the instruction to the motors and moves it. These batteries are providing the power to both the controllers and this cage is given power through this controller itself.